Hello friends, myself Rahul Tumar, working as an assistant professor at Dr. Subhash Technical Campus in Electronics and Communication branch. Today we are going to see the Coulomb's law example. Coulomb's law. Coulomb's law states that between 2 point charges there is a force F which will be the attractive or repulsive. Suppose both charges are the same, means both have the either positive or both have the either negative charge, then between them there will be the repulsive force, and if one is the positive and other is the negative, then there will be the force of the attraction. Suppose we have the charge Q1 and the other charge is Q2, both are located in a vacuum, then as per the Coulomb's law, force between the two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So that we can say that F is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Vector force due to the Coulomb's law. Now we know that the force is directly proportional to the charge between them and the inversely proportional to the square of the distance between them. In general, it can be write F is equal to Q1 Q2 upon 4 pi epsilon 0 r square. In vector form, it can be rewrite F is equal to 4. Suppose we say that this one is the charge Q1 and this is the charge Q2, and we require to find force on charge 2 due to the charge Q1, then it can be represented by force on charge 2 is Q1 Q2 upon 4 pi epsilon 0 r12 square, unit direction A12. Here r12 is the distance between the 2 point charge and A12 is represent the direction of the force here from charge 1 to the charge 2. Unit vector can be defined using the position vector, which can be represented like the, suppose the R1 is the position vector of the Q1 charge and the R2 is the position of the Q2 charge, then we can find the distance between them will R12 is equal to R2 minus R1, and the unit vector of the force can be represented by the R2 vector minus R1 vector upon magnitude of the R2 minus R1. Okay, using this formula, let's we try to find out the force with the help of example. Here in example we have given the charge Q1 is 3 cross 10 raised to minus 4 Coulomb, which is located at point M 1, 2, 3, and other charge is Q2, which is the 10 raised to minus 4 Coulomb located at point N 2, 0, 5. Both charges are in a vacuum and we require to find a force on Q2 due to the Q1. Okay, here we have given the charge Q1, which is the 3 cross 10 raised to minus 4 Coulomb at point M, which is the 1, 2 and 3, and the other charge is Q2. The charge of it 10 raised to minus 4 and located at point N 2, 0 and 5. Okay, both are the positive charge. So force here will be the repulsive in this direction. Okay, now as per the Coulomb's law, the force on charge 2 represented by the F2 is equal to the multiplication of the product of the charge and 4 pi epsilon 0 r12 square into a12 direction. Okay, if we find the r12 and a12, then put the value of q1, q2, 4 pi. Value of the epsilon 0 in a vacuum is 8.854 cross 10 raised to minus 12, or you can also put the value 1 upon 36 1 upon 36 pi 10 raised to minus 9. Okay, so let's first find out the value of r12. For that, let's figure out it. Here this one is the q1, this one is the q2. Then with respect to origin, position vector can be represented by the r1 and r2, and force on q2 due to the charge q2 is in this direction, and the unit vector is a12. Okay, so from this figure we can say that r2 is equal to r2 minus r1. Here r2 is the 205, means 2ax minus 0ay minus 5az minus r1 is the 1ax minus 2ay plus 3az. So we can say that r12 is equal to r12 1ax minus 2ay plus 2az, and unit vector can be rewrite a12 is equal to unit vector position vector r12 upon magnitude of r12. So first we find the magnitude of r12. It is the under root 1 square plus 2 square plus 2 square. So we get under root 9 is equal to 3. So position vector r12 is 1ax minus 2ay plus 2az upon magnitude of r12 is 3. So put the value of q1, q2 in the force formula, which is the q1, q2 4 pi epsilon 0 r12 square unit vector a12. q1 is 3 cross 10 raised to minus 4, q2 is the 10 raised to minus 4, and 4 pi 1 upon 36 pi 10 raised to minus 9. r12 value is 3 square. Unit vector is 1ax minus 2ay plus 2az upon 3. So we get, let's simplify it before that. So we can say pi will be the cancel out. 9 4s are 36. So we get here 9 will be go upside, so we can say 9 cross 3 10 raised to minus 4 upon 3 square 10 raised to minus 9 ax minus 2ay plus 2az upon 3. So we say that 3 raised to square means 9, so 9 will be the cancel out. 10 raised to minus 4 minus 9 means 10 raised to minus 8, and if we 10 raised to minus 8, so we get here, okay, if we rewrite this equation, then we get 3 cross 10 raised to minus 8 upon 10 raised to minus 9. Unit vector is ax 2ay 2az divided by 3 means ax vector minus 2ay plus 2az divided by 3. Again 3 will be the cancel. Three will be the cancel out, so we get 10 raised to minus 8 plus 9 ax minus 2ay plus 2az. So we can say that 10 into ax minus 2ay plus 2az. If we multiply vector by 10, then we get 10ax minus 2ay plus 2az, which is the force F2 on charge Q2 due to the charge Q1, which is the 3 cross 10 raised to minus 4 Coulomb.